For question 5, we want to describe the following relationships as either increasing or decreasing, but also as either concave up or concave down. We'll show our work to support and justify our choice. Okay, so when we're looking at these, you just want to look at the changes between the values, and you do technically need to pay attention to both sides, input and output. I think these questions were given relatively nice to us, which is good because you'll notice the inputs are all equally spaced, so we don't have to worry about dividing out, so to speak, by whatever the change of input is, because all of the change in inputs are just 1 unit apart. So increase by 1 for every single one of those values on the inputs. Now, the outputs are the ones that are going to really show us what's happening on this problem. So you'll notice these numbers, if you just glance at them, they're definitely going up. To get from 3 to 5 to 9 to 15 to 23 to 33, they're definitely going up. But the question becomes, how are they going up? So first it increases by 2, then it increases by 4, then it increases by 6, next it increases by 8, and lastly it increases by 10. So all of these values are increasing, but they also happen to be increasing by more and more and more and more. And that's what makes this one increasing, yes, but increasing concave up. So this is going to be an increasing, but also concave up relationship. And the reason is because for equal changes in input, the outputs are increasing, yes, but they're increasing by larger and larger amounts. And that is what makes it concave up. Okay, let's take a look at the next one. Once again, this problem is pretty nice to us because the inputs are all equally spaced again, just 1 unit apart. So that is lovely. The question that's more interesting will become, what are the outputs doing? So the first set, it has dropped by 11. The next set has dropped by 6. These values have dropped by 3. These values have dropped by 1.5. And these values have dropped by only a half. Okay, so when you look at these values, they're obviously decreasing. In order to get from 5 to -16, you have to decrease. To get from -16 to 22, you have to decrease again. All of these are decreasing. But how are they decreasing? So notice the amount of the drop is getting less and less. This is not as big of a drop as this previous one was. Similarly, -3 is not as big of a drop as -6 was. These values are technically increasing. On a number line, -6 is bigger than -11. On a number line. Yes, that is true. -6, oops. -6 is to the right of -11. Yes, it is technically bigger. -3 is technically bigger than -6 on a number line. So they're getting less and less negative, but technically that's because these values are increasing. So what that tells us is that it's going to also still be concave up. These rates of change, these changes are technically increasing, which makes it concave up. So if we phrase this, overall the table's decreasing. That is true, it's decreasing. The numbers are going down, yes, but it's decreasing concave up because for equal changes in input, the output is decreasing, but it's decreasing by less negative, also known as increasing. When numbers get less negative, it's because they're going up. Amounts, which is what makes it concave up. Anytime your changes are going up, well, that's concave up. And as weird as this one is, because it's negative, these changes are going up. To be less negative is to be increasing on a number line. All right, next one. Good news. They're equally spaced. This time it's by 2, but you know what? That's okay because as long as they're equally spaced, I can still just focus on what the output values are doing. If these were not equally spaced, I'd have to do my full-blown, change of output divided by change of input because that denominator is different every time. But it's not different every time. So because of that, I can just focus on what's happening over here. So what's happening over here? Well, the numbers are actually increasing this time. Definitely. They're getting less and less negative. So the numbers are going up. But how are they going up? Well, this guy goes up 16. This next set goes up by only 13. This next guy goes up by, what is that, 10. Then this increases by 6. And then this increases by 2. So notice, yes, they are all positives. They're all increasing, but they're increasing by smaller and smaller and smaller amounts. And that's what makes it concave down. So yes, the values are increasing, but they're increasing by smaller amounts, making it concave down. So this is an increasing but concave down situation because for equal changes in input, for equal changes in input, the outputs, the outputs are increasing. Yes, they are. They are increasing, but they're increasing by smaller and smaller amounts. And that is what makes it concave down. Okay, good. Last two. Let's look at some graphs. All right, so on these, first of all, you can just kind of glance a little bit at how the graph is behaving and already identify, I hope anyways. This first graph is definitely increasing because overall the curve is going up, but it's also increasing in a concave down fashion. I can just tell because it's almost like if I were to continue this path, I feel like I'm about to draw a frown. Boo-hoo. And so increasing concave down like a frown is already my inclination. But just to kind of verify that using the same logic as before, so if we look at equally spaced inputs, so 1 unit over, the graph goes up by about 8, right? I got all the way up to the 8th tick mark. But then for the next unit, it only goes up 3 and a bit. I don't know, 3 and a bit. Sure. And then for the next step over, it only goes up. Well, what is that? I don't know. It's maybe like the upper twos, maybe 2.5 units or something. Um, Actually, yeah, it's probably just over 2 units now that I'm looking at it more carefully, because this is one full box, and then these little extra slices, it's probably only 2 point something. Okay, but regardless, you can tell right now that yes, it's going up, but it's going up by smaller and smaller and smaller amounts, and that only confirms that it's concave down. So this is an increasing function. Yes, it is, but it's increasing concave down. All right, and then for this next one, again, I can tell just by glancing, this is a decreasing function. if I drive my car along this graph or ride my bike or rollerblade or whatever, snowboard, I'm going down the hill. This is a decreasing function. Okay, but how is it decreasing? Well, I can tell with my eyeballs again that this is a concave down curve, down like a frown. So I do feel, without even doing any math, so to speak, at all, that this is going to be a decreasing concave down function. But just to kind of verify that, let's do it again. So for 1 unit of X, it drops. And you guys, it drops just a little. Like, I don't know, what is that? Dropping 0.1, dropping 0.2, I don't know. Pick a number, dropping 0.2 maybe. Okay, then for the next unit of X, it drops. Okay, definitely more than 0.2. How much is that? Well, I don't know for sure. It's probably not quite 1 full unit, but it definitely drops more than it did before. Now we look at the next unit of X and it drops again. And that drop definitely looks bigger than the drop that came before it. How much bigger? I don't know for sure. Let's see, 1 unit would be like from here to here. So a little more than 1 unit, maybe? I'm estimating, I fully admit. And you can continue to see that with each change in X, it drops. Here it goes again. It dropped by almost 2 full units that time. Okay, so you can feel that these drops are getting more and more and more negative. Okay, so guys, if you think about on a number line, if your numbers are getting more and more and more negative, that is technically decreasing. -5 is less than -1. You're going down the number line. So this is a decreasing function, definitely, but it's a decreasing concave down function because of the fact that the changes are getting more and more negative, so the changes are actually technically decreasing. Anytime your changes are decreasing, that's how you know you're concave down. Um, didn't I have a concave down one up here? Yes, look, I knew it was concave down because my changes were decreasing. They were getting smaller and smaller. And that's exactly how you know when you're concave down. Oh, look, this was also concave down because my changes were decreasing. Anytime the changes are decreasing, that's when you know that you're concave down. Okay, there we go. Hopefully that helps shed some light on concavity. And you know what to do if you need help. Just reach out. We are here.